Okay, this is lesson 2.1 continued. This is example 1. Here we're given our function f is 1 over x plus 1, where of course x cannot be negative 1, otherwise we get an undefined there. And so let's look at symbologies first. We're going to use this upside down looking A, and that means all. And here we use this backwards looking E symbol, that means there exists. ST means such that. So if we're looking at this for all x, which is an element in our domain D, or belongs to D, or is within D, inside D, and we also have for all epsilon that's positive or greater than 0, there exists a delta that is greater than 0, or there exists a delta that's positive as well. For all some number A that's an element in our domain, we're saying that at the absolute value of our function f of x minus f of a, which is, this is the same number here, is less than epsilon. Whenever x minus some number a is less than delta. So if we're looking at this, right, here's a, here's our curve, here's our limit, f of a, and we're saying that we want to find some delta so that we have a plus delta and a minus delta. We want to find that range so that we can get within this range here, f of a minus epsilon and f of a plus epsilon. Okay, so that's what we're trying to get here. All right, so we're saying a is 1, okay, and epsilon is 0.1. So this would be f of a plus 0.1 and f of a minus 0.1. Okay, find a delta. So we've got to find what this delta is. We're saying, okay, we want to find within 0.1 from our limit, from f of a. So we're trying to find what that delta is. All right, so whenever the absolute value of x minus 1 is, well, here's our a, our 1. So we're looking at some value x somewhere within this range. X is going to be somewhere within this range. But it's less than delta, so it's got to be within this a minus delta and a plus delta range. Okay, so from here, all right, let's do this. We start off with absolute value of f of x minus f of a less than epsilon whenever the absolute value of x minus a is less than some number delta. So we're trying to find this delta here. That's what we're trying to get to. All right, so what we do is we know that a is 1. So we can say f of x minus f of 1 is less than epsilon, and we're saying epsilon is 0.1. So we can put 0.1 here. So we're going to have to, because this is absolute value, we're going to find epsilon at 0.1 and then epsilon at negative 0.1, and then we're going to take the minimum of both of those. and this is going to be whenever x minus, we know that a is 1, and we're trying to find delta. Okay, so f of x is 1 over x plus 1 right here. So we put in 1 over x plus 1 minus, so if we substitute f of 1 in, we get 1 over 1 plus 1. 1 over 1 plus 1, and that's less than 0.1. So from here we're going to start with finding positive 0.1, then we're going to look for negative 0.1. Okay, so this will be, we're going to get 1 over x plus 1. So since we're trying to find 0.1 and negative 0.1, we can go ahead and do away with the parentheses with the absolute value signs, like what we did on the board. Minus 1 over 1 plus 1 is 2, and then we're going to set that equal to 0.1. So we need a common denominator. So we've got to multiply x plus 1 over x plus 1. And we've got to multiply 2 over 2 to get our common denominator. So that's going to give us 2 over 2, 2x times plus 2. And then we can go ahead and combine these since they're all under the same absolute value. Minus, and then we would distribute this negative 1. So that'd be negative x minus 1 equals to 0.1. All right, so from here, we continue to simplify. So 2 minus 1 is 1. So that's 1 minus x over 2x plus 2. And that's going to equal to 0.1. Well, from here, we need to get rid of the denominator. So how do we do that? Well, we multiply, right? Multiply out the denominator, 2x plus 2, and we multiply 2x plus 2 to the other side. And so that cancels the denominator out, and we have 1 minus x equals 2, and here we can distribute, right? And we get 0.2x, 0.1 times 2x is 0.2x, plus 0.1 times 2 is 0.2. Okay, so from here, we want to combine like terms, so we can apply a plus x. This is a 1x, right? Plus 1x. And so that would be, you can either add 1 or you can subtract 0.2. I like to keep the x's positive. So this would be 1 equals to 1.2x plus 0.2. So from here, this is 1.0, right? Same thing as 1.0. So now we're going to subtract 0.2, subtract 0.2, and we get 1.0 minus 0.2. That'll be 0.8 equals to 1.2x. So we're going to divide 1.2, divide 1.2 to both sides. And so we get here x equals to 0.8 over 0.2. Well, if we multiply both sides times 10, right? I mean, multiply the numerator and denominator times 10, right? We move that decimal point. So that's 8 over 12. And 4 can go into both. So 4 goes in 8, that's 2. 4 goes into 12, that's 3. So we get x equals 3. So from that, we can plug that into this x here. So this x goes into that. So now we're ready to plug that in to find our delta. So this will be absolute value of 2 over 3 minus 1 would be 3 over 3, and that's less than delta. So from here, since we're going to get an absolute value, we know that we're going to get something less than delta. So 2 minus 3, that'll be the absolute value of a negative 1/3. And so absolute value of 1/3 is 1/3. So we're saying delta is equal to 1/3. Well, that's when 0.1 is positive. Well, what if 0.1, now let's look at 0.1 when it's negative. So now we're going to look at the same thing, 1 over x plus 1 minus 1/2 again is equal to a negative 0.1. So because of the absolute value, we're looking at positive 1 and now a negative 0.1. So again, we combine these, right, and we get the same thing here. 1 minus x over 2x plus 2 equals to a negative 0.1. So this number, what we did here and here is the same process. Okay, so now we want to multiply out the denominator again. So we're going to multiply 2x plus 2 and 2x plus 2 to both sides. So that cancels the denominator out, and we get 1 minus x equals to negative 0. Need some more room here. 1 minus x equals to negative 0.1 times 2x plus 2. Okay, so that's going to be 1 minus x equals to a negative 0.2x minus 0.2. So it was almost the same thing as what we did on the left side, except for this is going to be, this side one's positive and this is negative because we used negative 0.1 instead of positive 0.1. Okay, so now we apply plus 1x, 1.0 plus 1.0x. And again, we're going to get 1 equal to 0.8x minus 0.2. So now we're going to apply plus 0.2 plus 0.2. And we get 1.0 plus 1.2 equals to 0.8x. And so we divide by 0.8. And again, we're going to do that denominator times 10. So that was at decimal point, 12 over 8. So that's going to give us 3. 4 goes in 8 2 times, 4 goes into 12 3 times. So that's 3 halves. Okay, so what we have here is x equals, x is less than 3 halves but greater than 2/3. So When we're talking about in this range here, we're looking at, okay, we can use somewhere between 3/2 and 2/3. So what we want to do is we want to choose the smaller number, because that'll just get us closer to our epsilon that we were looking for. So therefore, delta is equal to 2/3. And that's it. We're done with that. Hold on. So we're going to use 2/3. Since 2/3, x equal 2/3, then we're saying that 2/3 minus 1, right? That's what we did here. 2/3 minus 1 less than our delta. And we ended up with 1/3. So delta is, our answer is delta equal to 1/3. And we're done.